So now that we've gone into that activity series and looked at what that can tell us about whether a single replacement reaction takes place, we can get into a little bit more about exactly what is going on when we say one element takes the place of another element. And single replacement reactions are sort of the easiest example, but synthesis, decomposition, combustion reactions, these and single displacement reactions are all examples of sort of an overarching type of reaction called an oxidation reduction reaction. An oxidation reduction reaction is a reaction in which electrons are transferred. Electrons are transferred, so that means one element will give up 1, 2, 3, 4 electrons and give them to another element. Here's an example of an oxidation reduction reaction. This is calcium metal and oxygen gas, just the oxygen that's in the air. Remember, calcium is an alkaline earth metal, which means that it has pretty low ionization energy, and it will be much more stable if it gives up its 2 valence electrons. And what happens is just through a natural process, the calcium gives its extra electrons to the oxygen. And so what forms on the outside is the now ionic compound calcium oxide, because when calcium gives up its 2 electrons, it becomes an ion, a positive ion, a cation. And when the oxygen gas gains the electrons, it now becomes a negative ion. So each one of those processes has a different name. Gaining electrons is one and losing electrons is another. Oxidation is when you lose electrons. And of course, if you lose an electron, that means you become positive, or you could become more positive. Reduction is the opposite of that. Reduction is when you gain electrons. Of course, gaining electrons, you could become negative. Right? The oxygen in the example above became negative. You could become more negative or less positive. So we're just going to have to really start thinking about, did this guy gain electrons or lose electrons? There's a handy mnemonic to help us understand this, and that's called oil rig. Oxidation is loss, reduction is gain. You will also hear Leo the lion says grr. Leo being loss of electrons is oxidation, and grr, gain of electrons, is reduction. Okay? So how are you going to tell? Well, basically you're going to have to look at the charge difference. What is the charge of the element on one side? What is the charge on the element on the other side? And how do those compare? And then by looking at how the charge changes, you can figure out, well, did it lose electrons or did it gain electrons? So how you are going to do that is for ionic compounds, right? Ionic compounds, you can figure out the charge. That's from the periodic table. If it is not in a compound, we assume that the charge, when we talk about this in terms of oxidation reduction, we can also talk about it in terms of oxidation number. It's just another way of talking about it, that for pure elements, it would be 0. So let's take a look at this first example. Potassium here starts out with a charge of 0. In the compound potassium hydroxide, it has a charge of positive 1. So what must have happened to it? Did it lose an electron, or did it gain an electron? And if you think about going from neutral to positive, well, it must have lost an electron. So we would say potassium lost electron, potassium was oxidized. Hydrogen I know this is in an ionic compound, but when it's with oxygen, hydrogen sometimes behaves like a metal. So we could think of it as having a +1 charge, because over here it is neutral. So if it goes from positive to neutral, what must have happened? It must have gained an electron, which meant that the hydrogen was reduced. All you need to do is say what element it was. Let's look at this next example here. Zinc starts out as being neutral, and zinc on the right-hand side, since it has 2 nitrates that need to balance it out, I can figure out that the zinc must have been 2 plus. So then how did it go from being neutral to being 2 plus? It lost electrons. It was oxidized. Copper goes from being 2 plus on this side to 0 on that side. So how does it go from being positive to 0? It must have gained electrons. And so that means that the copper was reduced. We can see this also with when we look at single replacement reactions with those nonmetals, right? Chlorine, any element by itself is 0. In the ionic compound, it has a charge of -1. So if it goes from being 0 to -1, it must have gained an electron, which meant that it was reduced. So chlorine was the one that was reduced. Iodine goes from being -1 to 0, so it must have lost an electron. So the iodine was oxidized. So these are 3 examples. And now what you can do is you can go all the way back to the beginning of these notes. I think maybe the beginning, I say page 12, that might have even been last year. But go back to the first time where I say what is oxidized and what is reduced. And you can go all the way back and now start figuring out, oh, which guy was oxidized and which one was reduced. So you might want to press pause here. Go back through your notes packet and try to practice those yourself. Who was oxidized and who was reduced, and then press play and see how you did. Okay, so the first time that we encounter this oxidized and reduced was way back here in when we talked about the different types of reactions. And remember, every type of reaction, basically except for double replacement, can be an oxidation reduction reaction. So let's look at this guy right here, sodium turning into sodium chloride. Well, sodium is 0. It becomes +1. How do you become positive? You lose an electron. So that means that the sodium was oxidized. I'm guessing chlorine was the one that was reduced. Let's double check that. He starts out as 0 and he ends as -1, which means he must have gained an electron. Reduction is gain. The combustion reactions are sometimes hard to figure out, so we're going to skip over those. Let's look at this example. This is a decomposition reaction, right? In mercury 2 oxide, mercury starts out as a 2 plus ion and then winds up being neutral. Well, how do you go from being positive to neutral? You have to gain electrons. So if you gain electrons, reduction is gain. We would say that the mercury was reduced and the oxygen goes from being 2 minus to 0, so it must have lost electrons. So oxygen was oxidized. Here's the other example. We saw this already with potassium. Potassium goes from being neutral to being +1, which means it must have lost electrons, which means potassium was oxidized and hydrogen was reduced. He goes from being +1 to being 0, so he must have gained an electron. Aluminum starts out as 0, ends as 3 plus. It must have lost 3 electrons. So we can say that the aluminum was oxidized. Copper goes from being 2 plus to being neutral. So that must mean it must have gained electrons. So we would say that copper was reduced. Specifically, the copper ion was reduced. Double replacement reactions, there's no electrons being transferred. So in double replacement reactions, we're just not going to see any of the examples of oxidation reduction. But this was the problem with all of the single replacement reactions. And so all of these, we should be able to figure out who was oxidized and who was reduced. Again, aluminum starts out as being neutral. He ends up as being 3 plus. He lost electrons. To become positive, you have to lose electrons. So aluminum was oxidized. Hydrogen is +1, and here it is 0, so it must have gained electrons. So the hydrogen was reduced. Remember, oil, oxidation is loss, reduction is gain. Copper, oh, that one had no reaction. Potassium goes to being potassium with a +1 charge. So potassium was oxidized and hydrogen was reduced. Chromium goes from having a charge of 0 to a charge of 3+. It must have lost electrons, so it was oxidized. And lead must have been the compounds that was reduced. It goes from 2+ to being neutral, so it must have gained electrons. And down here, fluorine has a negative charge here, and it has fluorine has a 0 charge there and a -1 charge on the product side, which means he must have gained electrons. So we would say fluorine was reduced, reduction is gain, which meant bromine must have been oxidized. It has a -1 charge at the beginning and a 0 charge at the end. So it was oxidized there. So as long as you can remember who gets oxidized and who is reduced with the oil rig, you'll be fine in these problems.